For this week's Ask Away, we're talking about lightning. With the stormy pattern that looks to set up into this weekend, it will be a timely topic, and one of our anonymous viewers wants to know what makes lightning appear green when it strikes the ground or strikes in the cloud. So we'll talk about that, and it all has to deal with the periodic table, believe it or not. So we'll look at all of the elements of this periodic table. Some of them deal with colors. Our lightning colors, this is the same process as fireworks. That's why you're seeing the fireworks going off in this graphic. Some of them, including strontium, includes that red color that we see when lightning charges the atmosphere. It interacts with that element, and we see red lightning. Calcium would be orange, sodium would be yellow, barium would be green, copper, blue, and there's two subsets of copper. One could be purple, and of course strontium could be purple as well. You have magnesium, aluminum, all those, titanium, could also be that white color that we're seeing more prominently. So what even is a lightning strike? How does it even form? Well, we have in the upper layers of, say, a cumulonimbus cloud, a storm cloud, those ice crystals are forming and accumulating as liquid raindrops are freezing. It's all being pulled up in the updraft of the storm. In the mid-levels of the storm, that's where we have a mixture of some liquid, some droplets, and some ice right near that freezing level several thousand feet above the surface. Now, as we see this storm growing, it starts to become charged. Ice crystals in the very top of the storm are positively charged. Hail in the mid-levels of the storm, they start to become negatively charged. And of course, the ground at the surface is positively charged. So we know what happens with static electricity. Those two charges interact with each other, and that's when lightning strikes. It's trying to offset the large charge differential, the imbalance in between that negative charge in the storm and the positive charge at the surface. And that's why we see those bolts. It's, of course, electricity, a lot of power there, and that's how this all occurs. So thank you for sending in that question. If anyone has any question related to weather or science, please send it in to weather@kimt.com, and I'll be sure to answer it over the coming weeks.